All right, welcome back to part 2 of the assignment now. We're going to just keep moving on to electrostatics and looking about just a little bit more specific about static electricity, what it is, how you can tell what kind of charges will be made and those kinds of things, and detecting charge a little bit. So you can keep going on. We're looking at this page right now in the booklet where it says electric static. Now, have you ever dragged your feet on the carpet and then touched a metal doorknob? What happens? A spark. Why? Why does this plus metal touching equal spark? That doesn't really make a lot of sense unless you understand how electricity works, because you've built a charge. You are imbalanced. You have an imbalanced charge, and by touching a metal object, generally metal objects are ground, or what we call grounding. And grounding is when you return a charge to normal. Those electrons go back and balance. So what you're doing when you're touching a doorknob with a charge is you're restoring everything to neutral, and some electrons are going to move either from you to the doorknob or from the doorknob to you to balance things out again, and that's going to create a spark in some cases or feel a shock. So now we can move on here. What is static electricity? Let's just take a look at that. So objects can be charged when electrons move from one object to another. The electric charge that builds up on the surface of an object is called static electricity. And I'm going to just give you something here. I'm just going to get you to start, because remember, part of your assignment is making notes. So we're back on this note sheet here. So now I'm going to say static electricity equals surface energy, and it stays in place for a while. That's something to know about static electricity, right? It's normally surface electricity, and it's static as in does it move. When something is static, it doesn't move. So if you need to pause that to catch that up, just pause the video, and I'm going to keep moving on. All right, let's take a look here. So now, when you rub two objects together, there's a transfer of electrons between the two. We kind of are getting a feeling for that. Now, the particle model of electricity tells us how this is going to work. The particle model of electricity states that when two objects are rubbed together, electrons are removed from the atoms of one object, and those electrons are moved to the second object. If you gain those electrons, you become negatively charged. There's nothing too crazy there, right? But if I'm doing what I'm telling you before, two objects, and you'll see right away why we pick these objects, because they're on opposite ends of the electron affinity scale, which we're going to get to right away. So if I take this and this, remember I already kind of cheated and told you this will become a positive rod. So right now they're neutral. I've touched them. They're just neutral. Everything's good. No charges. But when I rub them, you're going to have to take my word for another minute or two. But this has become positive, and this has become negative. So where did the electrons move? Did positives move? Did protons move? No, protons never move. That's in your notes. The electrons moved from this rod to this bag by friction. That left this rod positive, and that made this bag negative. By rubbing them together, some electrons went from one object to the other. Therefore, one becomes positive and one becomes negative. And you can use a chart called an electron affinity chart to decide if I rub this and this, which one will gain and which one will lose. If I rub this and this, which one will gain and which one will lose. And we can use that electron affinity chart to predict charges like this. I'm just going to put that back. So I'm trying to give you a little bit of a preview. That glass rod, you got to be careful because it'll shatter. So nothing too crazy. Nothing that you need to write down, because you should know that when you rub two things together, some electrons are going to transfer. If you lose electrons, you become positive. If you gain electrons, you become negative. That's just kind of common sense. Think about that if you need to, or consult your notes. Now, this is cool. This is where we get into which things give and which things take, right? What is electron affinity? Well, different substances have different abilities to hold on to electrons. The tendency to hold on to those electrons is called electron affinity. So there are going to be some objects that really want to hold their electrons, and there's going to be other objects that really like giving them away. And if you look at the document here, this is a really great chart. Let's take a look. So right here, you can see that I'm going to move my mouse. These kinds of things tend to lose electrons, so you can see they become more positive. And these types of things tend to gain electrons, so they become more negative. And now, some of the things that we're going to use are glass. We're going to use, where is something like a vinyl or a silicone, which is that rubber rod we're going to use. Then we're going to use stuff that's like a wool or a hair, and we're going to use something that's like a celluloid or a urethane. So we're going to use some things from down here and some things from up here, because the further apart they are on that chart, the further apart they are, the more they lose and gain. If they're close, they barely lose or gain any electrons, but if they're far apart, they lose or gain a lot of electrons. That was why we use glass rod, which is, if you look here, glass rod is right at the top, so it likes to lose electrons, and I'm going to rub it with a bag that's made out of these kind of plastic materials down here, you can see, and these materials like to gain electrons, so that's why I kind of stack the deck. I make everything really optimal for this situation. So I say, I've got something that really wants to lose electrons, and I got something that really wants to gain electrons, so I can cheat and basically guarantee that I've made a positive rod by the end of it and a negative bag, because I know about that electron affinity chart, and I've chosen two objects that are really going to make a charge. Likewise, if I use fur, which is kind of up in the wool area, nice up at the top, and I use something down here like a rubber rod, I can make that rubber rod really negative. So I can make a positive rod, or I can make a negative rod with a rubber rod and fur, just by looking at where that electron affinity chart is. So that electron affinity chart is really quite cool. It's going to tell you which things gain electrons and which things lose electrons. So that's what electron affinity is, and I'm going to get you to write a little bit of notes here. Nothing too crazy, right? So let's just go to the document, Cam. Electron affinity equals object's ability to hold or lose electrons. And I'm going to write some examples. Rubber rod, it likes to gain electrons. Glass rod likes to lose electrons. Fur, if I rub fur with that, it's going to lose electrons. And I could say that a plastic bag will, a glass rod, sorry, plastic bag will gain electrons there. So you can see a rubber rod is going to gain electrons, so it will become slightly negative. A glass rod will lose electrons, so it will become slightly positive. Fur will lose electrons, so it will become positive. And a plastic bag will gain electrons, so it will become negative. That's kind of cool. That's what you got to be writing down there. So you can pause it if you want to, but that's what electron affinity means. Electron affinity basically means, I'm going to switch here, look at the chart and see if it's going to gain or lose, because you know whether that object will likely become positive or negative when you rub it. And for our purposes, we're not using a million different objects or anything. We're using glass rods with plastic bags, rubber rods with fur. That's kind of the end of it. That's what we use because they're the most easily available and ready to use kind of lab equipment that we could get that really gives a strong charge when you rub them together because of that electron affinity scale. So now we're going to talk about, if you look here, I'm just going to move down. How do you transfer these electricity charges, okay? So that's what we're going to talk about. And you don't need to worry. I'm going to get rid of this paper. I'm just going to get another one for you. But when we talk about transferring electrons or transferring charges, how can you transfer it? Well, what I mean is if you made that charge, like how can we put it on something else? How can we give it to another object or take charges from objects? Well, there's two ways. There's something called conduction and there's something called induction. Conduction, you've probably heard the word conductor. And induction, you might have heard of like induction cooking or something like that. Induction's a little bit more complicated. And now, one thing I'm going to tell you is if you don't quite get conduction and induction in this lesson, that's okay, because the next lesson coming up, we go into a lot of detail about conduction and induction. So right now in your notes, all you need to do is kind of take a look at these slides and follow along with me and write the basics about conduction and induction for right now. So let's take a look at this slide. How can you transfer the electricity? Well, there's a couple ways. The first is conduction. Conduction is charging an object by touching it with something that is charged. Okay, so conduction is making a charge by touching, and then if you look down there, induction is making a charge, right, by bringing a charged object close to it. But you don't have to touch. Now, I'm going to be honest with you here. Sometimes the way that they talk about induction is a little confusing because there's kind of like two versions of induction. So I'm going to show you right now. I'm going to kind of cheat and go a little bit ahead into the next lesson for a second to give you an idea of this. So this is kind of cool. I've got this little apparatus here, all right? And we're going to learn a lot more about it right away. Let's just write the notes for a second here. So let's go to the document. So I'm going to write conduction equals charging by touching, and induction equals charging with no touching. And then I'm going to put a special star here. Can also add grounding. And you might not know what that means yet. That's okay. I'm going to explain that right away because this is why I said induction's a little bit weird. So if you need to pause that, go ahead. And I'm going to give you one more definition here. I'm going to say grounding. Grounding equals touching a charged object to something metal or connected to Earth. Something that's physically connected. So, okay, pause that if you need to write those down for a second. This is kind of an introduction there. This is going to be kind of where we're spending our next lesson. So pause it if you need to, and I'm going to come and look at you for a sec. So grounding means I got a static charge and I touch that metal doorknob. That metal doorknob's got lots of electrons ready to go or take. It can take or give. It's always good. It's going to balance me out. So when I touch this, if I'm really negative and I touch it, my electrons will go to the doorknob and now I'm grounded. I'm back to neutral. That's called grounding. A lot of times, if you work with electronics, they'll have something connected around your wrist, connected to a piece of metal at the table you're working at, so that if you're working with electronics, you don't fry them by being too statically charged by rubbing your arms and stuff and rubbing the table, because you can make small static charges just every day by moving and touching things. Anytime two things rub, there is a small static charge built up, so you could become charged and you could fry electronic components. So if you have a metal wire touching your body, touching a metal desk or something, you will always get rid of that extra charge and you won't hurt your electronic components. Another way people like to ground to connect to Earth is by touching metal plumbing. So if you touch a sink or you touch a water pipe or something like that, it's pretty cool because that's connected physically. Those pipes eventually run into the Earth. They're connected to the city and things like that. They're actually connected to the ground. And the way the ground works is the ground's got so many protons and electrons, your static charge isn't going to throw the balance of electrons off in the Earth. It's kind of an infinite giver and taker of electrons. The Earth will always restore your balance to zero. So if you're positively charged and you touch Earth, you will become balanced. If you're negatively charged and you touch Earth, you will become balanced. That's what grounding is. Grounding is connecting to Earth to restore charges to neutral. That's a really simple explanation. Now, let's see what else we can do before I give you some demonstrations. We're almost on the last page. So we've talked a little bit about conduction and induction. Let's look at the rest of the slide, and I'm going to give you a little bit of a demonstration, like a little bit of a sneak preview. All right, so there we go. Electrostatics is simply the buildup of electric charges on an object. There's three types of charges: positive, negative, and neutral. You know that. A static charge is an electric charge that stays in place for some length of time. They are often produced when materials are rubbed together. That's all stuff we've talked about. And this is what I'm going to use for this demo. So you can detect a static charge by using an electroscope. And the rules of static electricity are the effects of charged objects on one another and neutral objects can be summarized in two rules. Objects with like charges are going to repel. Objects with unlike charges are going to attract. And charged objects will attract neutral objects. So let's write that down. That's our last kind of summary on the document, Cam. So we can say like charges repel. For example, if you had a positive charge and a positive charge and they were beside each other, they would want to go away from each other. Unlike charges attract. So if you had a negative and a positive, they would want to go towards each other. That's the second rule. So that's one rule, two rules. Another one, neutral. So something with no charge equals attract too. So if you had something that had no charge and a positive, they would actually attract. If you had no charge and a negative, they would still attract because that neutral just gets sucked in. And if you had no charge and no charge, do nothing. So I can pause that if you want. You can pause that to get that. That's our last summary of how charges move. It's important to know that things that are the same repel, because we're going to need to know that very shortly in the other work we're going to do. Things that are different really attract. Things that are neutral will attract to a charge, and two neutrals beside each other will just sit there and kind of do nothing. So that's the kind of rules of that. Now, I said I was going to give you a little bonus thing here, right? Because this is what we're going to do. Yes, and you can use an electroscope. We don't need to worry about that because I'm going to show you what an electroscope is right now. So that's the end of your notes. So if you've done the 3 pages of notes I've done, you probably wrote them better, neater, smaller, and more organized than I did. But you need to take pictures of those for your assignment, and you also need to take pictures of your work, right? The electricity assignment. Describe the one fluid model, blah, 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 blah. You need to do that. And I'm going to give you a couple answers right away to help you out. So I want to show you something here. The way that we detect a charge is using something called an electroscope. That's 2 pieces of metal, and when I touch it, I've grounded it, and it has no charge. So I'm going to use a new camera here. Take a look at this. All right, we've got an electroscope. It's insulated. This metal is not touching anything in the world. It's got a rubber thing insulating it, so these 2 metal leaves are kind of free hanging in the universe, not affected by anything. I can touch this. It's not going to change anything because that rubber there insulates this metal. So this is a totally grounded, I'm grounding it, 2 metal strips. Now, if I charge them, if I make this all negative, those sheets are so light that if I make them positive, for example, positive and positive will repel. So let's see what I do here. I know for a fact that a glass rod and a plastic blade makes a positive rod. So if I touch them, watch. Because I've taken, this is really positive. This rod is incredibly positive. So what I do is I bring it close. The positives in this metal ball are like, ugh, positives, ugh, they go down here. And the negatives are like, oh, positive, I want to jump, I want to jump, I want to jump, I want to jump. And the negatives are attracted, so when I touch, the negatives jump onto my rod, making it neutral, but I have left this, I've stolen its negatives, and I've made this electroscope positive. Because look it, that leaf's positive, and that leaf is positive, and what do 2 things that are the same do? They repel. They don't want to be together. Now, I could simply reset this electroscope by grounding it. All I have to do is touch it to something, like my body, if I'm touching a piece of metal, like the bottom of this desk. And when I touch it, all the charges will be restored. I'll give it back some electrons. Watch. Oh, sorry, it caught the side of the thing, right? When I touch it, boom, it's back to normal. So let's do that without. So I'm going to make it positive. Positive rod, the electrons are going to jump to my rod. That means there's a lack of electrons, which means this whole thing has become positive when I leave. Positive and positive, they don't want to touch each other, so those little leaves repel. And when I ground them, back to neutral, because I've given some electrons back from my body, which is a good source of electrons, especially if you're touching something metal. So this is called an electroscope, and we're going to learn about that next. And that's an example. So what I want to show you before we go is by touching to make a charge. Watch, I touch the charge. I have conducted a charge. I've made a charge by touching. That's conduction. I can reset it. I can also make a charge without ever making this rod touch. And this is where, when I was talking about how it gets a little bit weird, this is what I'm talking about, all right? So I'm going to make a positive charge. Now there's two versions of induction, and I'm going to show you them both. It's kind of like induction simple, induction advanced. So the general definition of induction is just this. Watch, I've made a positive rod. I bring it close. Just by doing this, I'm making the leaves move. That is considered induction. I have created a charge down here without ever touching it. But as soon as I remove the rod, the charge is gone. So that's not super useful sometimes. It is still, technically speaking, induction. By bringing something close, I have created a charge down here. Now, one way that I can leave that charge is by connecting ground. And man, this is cool. And I'm getting good results today, so I want to show you. Watch this. I'm going to make this charge. I'm going to bring it close. Now remember, my body here, my finger, is a source of grounding. I can balance electrons. So right now, when I bring it close, all the negatives are like, oh, I want to jump to this positive. And all the positives are like, ugh, gross, I'm hiding down here. And that's why those leaves are separating. This is positive down here, and this is negative. So if I touch my body to it, all those negatives that are here that wanted to jump to there are going to jump to me instead. So I can take this, and I can leave a charge after. That's cool. I never touched this rod to it, but I made a charge in the end by using grounding. So I brought a charge near, I grounded. That's like what I consider induction 2.0, and we're going to get into that. If you don't understand that yet, that's okay, but you're starting to get the idea of where we're going. Because watch this, if I bring this positive rod to it, so I've got a charge here. I don't know what charge this is. I just know that it's charged because it's repelling. So if you see here, I don't know what the charge is, but it's repelling. And I got this positive rod, and the leaves actually closed now. That's really weird, and that's the magic that we're... Why, when I bring this rod, now it... What? Huh. Weird. That's what we're going to learn about next lesson. We're going to learn about detecting charge, transferring charges, and figuring out what charges are using rods and electroscopes. Now, I'm going to give you some answers. If you stuck around through 2 videos this long, come on. You deserve a break. So, sounds like I deserve a break. It's like every time I film, the bells go off. But I'm going to give you a couple answers here because your assignment was to take all those notes and take a picture of them and submit them to me in the classroom and to do this assignment right here. And your assignment is this, right? Electricity assignment. Describe the one fluid, you can do that. Describe the two fluid, describe the particle theory, protons, neutrons, electrons. What is an atom? You can do that. What is static? What is electron affinity? Conduction and induction, grounding. I gave you the definition. And describe the difference between conductors and insulators. I will help you with that one right now. I will say conductors let electricity flow, and insulators, sorry, that's rattling, do not let electricity, sorry, my pencil's running out, flow. An example would be glass. Glass sucks at letting electricity pass through it. And an example of a good conductor would be a metal wire. So that's something to help you out on the last one because that's not really on there. So that's that. This is a long lesson. I'm going to give you 2 days to work on it because it's kind of two things put together. So remember, your job for today is to have all those notes and do the sheet, submit them. And when you're done, if you got free time, watch the video of Dr. Julius Sumner kind of explaining induction, conduction, and having a lot of fun with statics. He even tries to move a big board with statics. So thank you for bearing with me. This was a long lesson. It was a two-parter, so I apologize. It's like 40 minutes of me teaching and you're taking notes, so we'll give you some time. I really appreciate you sticking around. This stuff gets cool. The next lesson is like a little bit similar to what we just did at the end, and then the one after that is a statics lab that I'm going to do with you, and we can kind of work on together. And it's just really fascinating. So we'll see you really soon, and take care, folks. I hope you're staying safe, and be well.